Welcome to Study Loop.
Our question says that a tiger leaps horizontally from a 7.5-meter high rock with a speed of 3.2 meters per second. How far from the base of the rock will she land? Okay, so to solve this question, we are going to choose downward to be the positive y direction, and the origin will be at the point where the tiger leaps from the rock in the horizontal direction. I wrote at the top of the screen above the line what we were initially given in the problem, which that the velocity in the x direction, which I put as v of x 0, is equal to 3.2 meters per second. The velocity the acceleration in the y direction is 9.8 meters per second squared. That's due to gravity. And because she leaps horizontally, there's no initial velocity in the y direction. And so it's equal to 0, as well as the acceleration in the x direction. It's equal to 0. And the total distance in which she's going to travel will be 7.5 meters in the y direction. So I write y is equal to 7.5 meters. And that what we need to figure out is the time it's going to take for the tiger to hit the ground. If we know how long she's in the air, and we assume she's traveling at the v of x value, the velocity in the x direction value of 3.2 meters per second, we'll be able to figure out by multiplying the velocity times the time how far she traveled in the x direction horizontally. Okay, so we're going to be able to use equation 2-12b and apply that to the vertical motion to find out how long she's in the air. Okay, so this equation says that y is equal to y naught, right, plus the velocity in the y direction, okay? And we need to multiply this by time. And this just intuitively makes sense because velocity is meters per second. And in order to add that to something that's in meters, you need to multiply it by something that's in seconds to get velocity, to convert velocity into seconds. And that would be time. And then here we have 1/2 at squared. And again, you know that there must be a t squared here because this is meters per second squared, and we need to get it into meters. And the 1/2 just comes as a constant of integration. So this is just a way of maybe kind of remembering this without completely having to memorize it. Okay, so now let's plug in what we know. Well, y, the distance it's going to travel, is 7.5 meters. That's how far the tiger travels, right? Well, we said that the initial y value is going to be 0, and she's going to travel a total of 7.5 meters. So y naught is 0, okay? And v of y naught is also 0. So v of y naught times t is going to be 0. So the first two terms are 0. So that means we only have to care about the last term. So it's 1/2, and then it's 9.8 meters per second squared, meters per second squared, because it's acceleration, multiplied by the time that the tiger is going to be in the air, squared. Well, now all we have to do is solve for t. So t then is going to be equal to square root, because it's squared, so we're going to have to take the square root. The 7.5 meters is going to get multiplied by the 2 from the 1/2. Okay, and then it's going to be divided by the acceleration in the y direction, which is 9.8, and that is, there's a point there, meters per square second. Okay, so the meters are going to cancel. The seconds squared is going to get rooted, so it's just going to be left with seconds, which is the units we expect. And if you carry this out, it's 1.24 seconds. So now we know how long the tiger is going to be in the air, and how long it's going to be traveling. So now we can figure out how far it travels in the x direction. That's going to be the distance it travels is going to be the velocity at which it's traveling at, which is just v of x 0, because we assume it travels at a constant velocity the whole time. And that's going to be multiplied by the time. Okay, so let's plug in these values. This is 3.2 in meters per second, multiplied by the 1.24 seconds we just found. Seconds cancel, we're left with meters, which is what we expect because it's a distance measurement. And this is 4.0 meters. Okay. Go ahead and box that in as our solution.